Hi everyone. Today we're going to look at strong acid versus strong base titration. Now we kind of did this already back in December, I think, before Christmas holiday. We did this as an experiment. Now when we did this, it was based on the knowledge that we had for topic 1, looking at concentration, and on top of that, looking at stoichiometry. Now, after we learned about topic 8, which is knowing how to find pH of acid and base, then we looked at finding pH of strong acid versus weak acid, strong base versus weak base. We haven't really talked about titration curve, which is quite important if you ask me. Okay, so today we're going to look at titration curve. Now, how will pH change as you insert more and more base? Well, today we're using base as your titrant. So this is the reaction that we're trying to accomplish today. Your strong acid will be hydrochloric acid. Okay, that will be your, unknown inside your flask. It's no longer unknown because I'm going to tell you right now that this is going to be 0.1 molar. And inside that flask, there is 25 milliliter. Okay, you're gonna react this with a strong base, sodium hydroxide. Okay, we can agree that this is indeed a strong base, and this is gonna be 0.2 molar that you will put in your burette. Now, the volume of this will change because by inserting different amount of volume each increment, we want to see exactly what the change in pH is going to be. Then we're going to graph it in this graphing paper that I have assembled for you. All right, so we're kind of going to go back and forth, and we all know that this reaction produces water. This reaction produces sodium chloride. Okay, is a one-way reaction because this reaction is not going to go backward because this is not no equilibrium reaction. All right, so our interest right here is to change this number. We're going to incrementally increase this number to see how the pH change. All right, now the first thing that I might want to do is find out how many mole is in here. Okay, to do that, all you have to do is take the concentration and multiply it by the volume. Now, this is something that you already know how to do, I hope. If you don't remember how to do it, I guess now you remember. And this will give you 0.0025 moles. Okay, so that's how much mole HCl you have in your flask right now. Okay, all right. Let's take a look at number 1. Okay, the first thing that you might want to do when you're given in this situation is to find out what is the equivalent volume. Okay, what is the equivalent volume? Find equivalent volume. Meaning that I want to know what volume of NaOH would you get? Will you reach endpoint? Okay. Now, if you remember correctly, the way to reach endpoint is when the number of moles here equals the amount of moles here. So the amount of mole here is 0.02025 mole. So whatever this is, which is the concentration, what volume do you need to reach the same mole? Okay. The good thing about this thing, of course, is that this is 1:1. If this was 1:2 something else, there's going to be a little bit more work, a little bit more stoichiometrical work. But no big deal. We will find out right now. And let's do this calculation. To find equivalent volume, you want to know, again, the number of moles of HCl. Okay, by multiplying its concentration with the volume that you are given. Okay, Given that, we know that for every mole of HCl is equivalent to a mole of NaOH. If this was an NaOH but something else, obviously the ratio would be different. Moles and moles cross out, HCl and HCl cross out, and the number of mole of NaOH that you will need as a requirement here is 0.0025 mole. Not surprising, because NaOH and HCl is again 1 to 1. So the amount of mole here obviously should be the same. Okay. Now, what's different here, of course, is the volume. Don't tell me that you're going to put 0.025 liters here. It's not. Just do this calculation and you'll know. Okay. So volume in this case, of course, is 0.0025 mole. Divide that by 0.2 moles per liter. Okay, moles and moles cancel, and you're left with volume. That will give you a volume of 0.0125 liters. Okay, so that's 12.5 milliliters of NaOH to reach endpoint. You drop too much, you're going to have to do it over again. Remember all that? Remember how crazy it was? So I guess I'm going to put it right here for now in orange, that to reach equivalent point, this is the volume of titrant you will need. Okay? That's great enough. But that information we will leave later. It's not really that useful of information because that's not what I want to find today. So let me just, hopefully you're writing this down, and let me just erase all of this and take a look at number 2. Okay, this is the meaty part of this lesson. It's to find the pH. So number 2. Okay. Part A. What is the pH when 0 milliliter of NaOH was added? So you haven't added any NaOH. So if you haven't added any NaOH, so let me just draw a little beaker right here. Okay, should have been a flask. Never use a beaker. So all you have right here is a whole bunch of H plus. Let me draw 4. Let me do 5. And a whole bunch of Cl minus. Cl minus is a halogen. All right, so 5 H plus and 5 Cl minus, and you're not dropping any NaOH in here, right? So if somebody were to ask you, what is the pH of this? That's pretty simple, okay? You're really just gonna negative log that number, aren't you? So let's do that. Let's refresh our memory. So pH, when no basis is added, is basically whatever the concentration of acid at this moment. So that's negative log of 0.1 molar. Okay, put that in your calculator and you'll notice that the answer is 1. Okay, log base 10 of 0.1 is 1. All right, let's graph this. Okay, so what I have here in my x-axis is the amount of NaOH added. So I started here at 0. And the pH at 0 is 1. So let me just put a point right here. That will be my first plot. How would this run? Well, I don't know. Let's see. All right, so that's part A. Let's move on. Let me erase this. It's going to be a lot of erasing. Okay. Part B. What is the pH when 5 milliliter of NaOH was added. Okay, so here it is. NaOH. You're going to add NaOH in here. Woo! What's going to happen here? Well, NaOH is going to separate. So you're going to have Na plus and you're going to have OH minus in your solution. Okay, now what's going to happen in your solution? Like all neutralization reaction, you're going to get OH and H finding each other. Let's draw that down. They're going to find each other to become water. Now, the thing is, will Na and Cl find each other to form sodium chloride? Yes, but they're not going to stick together. Because we know from yesterday's lesson that these guys are ions, right? They're soluble. They're going to remain NaCl. Unless somehow you evaporated all the water out of here, then of course Na and Cl will come together and form a crystal. But not right now, because water is not going anywhere. Okay, in fact, you're making more water in this case. So Na and Cl actually stays together at this moment. Okay, sorry, Na and Cl will stay separate at this moment. All right, let's do part B. Now, I want to know what is the pH when 5 milliliter of NaOH is added. So I drew exactly what I meant to draw, is that I dropped, let's say, 1 NaOH, and of course, you'll notice that one of the H became water. So if you think about it, do you have more H's or less H's now than before? Okay, before we had 5 H's, right? Now we have 4 H's because one of the H's got married to an OH. So this is less acidic, isn't it? What that means, you should expect a pH above 1 because that's where we started. So the next plot should be a number higher than 1. If not, something is wrong with you or your calculation. Now, the question is, how are we going to do that? Okay, how are we going to figure that out? Well, first of all, we know by drawing this, one of the H plus is taken away by an OH. So we want to know how much H plus remained after 5 milliliters of NaOH was added. So first what you want to do is figure out at 5 milliliter and at 0.2 molar, what is the mole of NaOH? Because by knowing what's the mole of NaOH, you can use stoichiometry to find the mole of H plus reacted. Subtract that by this number and you know how much HCl is left. Simple, right? Let's do it. So we have 0.2 moles per liter of NaOH. Okay? And we added 5 milliliter. Okay? Liters and liters is cancelled, so you're left with mole of NaOH. As I said, with mole of NaOH, using stoichiometry, how much HCl is going to be reacted. So 1 mole of NaOH will grab 1 mole of HCl. Right? 1 to 1, right? Again, 1 to 1. Mole and mole cancel, NaOH and NaOH cancel, and your answer is going to be 0.001 mole of HCl. Okay, so let me reiterate what I just said. With 5 milliliter of NaOH at 0.2 molarity, it will react 0.001 mole of HCl. So this amount of HCl is going to be reacted to make water. So how much HCl do I have left? It's almost like saying how many H's do I have left? Well, I know for a fact that I started out with 0.0025 mole of HCl, right? We make this calculation here and I said it's going to be useful. And 0.001 mole got reacted. So subtracting the two number, this is how much H plus I have left. Okay, so now I know how many moles of H plus is there. Now, don't be too excited and start negative logging that, because that's not no concentration. So that means right now we're going to have to find concentration of HCl. Okay, we know the mole. We know this is the amount of HCl that is left. How much is the volume now? We know it's not 0.025, but we do need 0.025 because that's how much it was in the flask originally. And then we added another 5 milliliter. This is the new concentration of your solution. Okay, put that all together, and my math skill says this is going to be 0.0. Oh my god. 5. Okay. So pH is equal to negative log of 0.05. And my calculator says around near 1.3. Okay. Now, ask yourself this question. Before NaOH was added, it was 1. 5 milliliters of NaOH was added, now it's 1.3. Does that make sense? Absolutely, because you have less H+. Less H+ means you're becoming less acidic. pH should increase. So let's put that down into our lovely chart here. So at 5 milliliter, okay, your pH is now 1.3. So my next dot should be around here. Okay, 1.3. I think I'm making these dots a little too big, but who cares? So it's not that big of an increase. Okay, it's a very slight increase. Let's add more. All right, I'm gonna erase some of these things. Okay, now I'm not gonna erase everything. I'm just gonna erase certain numbers because some numbers are really still the same. And hopefully you know why. Oh, you know what? I really should keep this number. Okay, I hope you know why. Yes, I am lazy to write all of those back. Okay. Part C. Part C, let's say, I don't know, 10 milliliters of NaOH added. Now, you should think, am I just picking these numbers out of random? No, I'm actually not picking these numbers out of random. Okay? I'm trying to approach closer and closer and closer to this equivalent point. Okay? And I don't want to just make up a number like, hey, 25. Then you know for a fact, hopefully you know for a fact that went over because you went over the equivalent point. When you go over the equivalent point, your math will be different. So I'm trying to stay before the equivalent point. Just try to get close to let you see what's going on. All right? So I erased some of the information that will be changed because some information is really not going to change. Like, you know, this is not going to change. These are not going to change. Okay, which means this is not going to change. All right, let me go back to my cool diagram here. Okay, so right now what happened? I don't know. Let's say I added 3 moles of this. So that means I added another Na plus, another OH minus, another Na plus, another OH minus. Okay, because of that, I'm actually generating more water. Woohoo! Because I'm generating more water, look, I have less H plus now. Because I have less H plus now, what can you expect the pH going to be? Would it go up, 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 or would it stay the same, or will it go back down? Of course it will go up because pH will be less acidic. And let's prove that's the case. So let's continue with the math. Okay? So I want to know, again, how much NaOH, okay, in moles that will react with HCl. All right? So let's do the same thing we did before. So 0.2 molar of NaOH times 0.01 liters. Okay, liters cancel. The ratio of NaOH and HCl, that's not going to change. That's always going to be 1:1. Because of that, oh, my math got a lot easier here, 0.002. Okay, so with 0.2 molar at 10 milliliters of NaOH, it will react 0.02 mole, or react out 0.002 mole of HCl. Okay, so let's do the subtraction again. So originally, as I said, we have this amount in moles. You add 10 milliliters, well, these amount will be reacted. Okay? And because of that, this is how much HCl you have left. Number is getting less and less and less, just like what we drew here. The number of H is getting less and less and less. All right, concentration time. Okay, so this is how much is left, right? What's the final volume? Okay, so I started with 0.025 liters, and I added another 0.01 liter. Okay, by doing the math, it's going to be 0.014, okay, molar. Let me know if I'm doing the math wrong. All right, plug this number in. Oh, I forgot to raise the pH. It's no longer 1.3. Okay, so negative log of 0.014. Let me get out my calculator. Can't do this one in my head. That's 1.85. Okay. Hey, it went up. It didn't went up much though. You added quite a bit of NaOH, but it really didn't go up much. So 1.85. So number of titrants. So here at 10 milliliters of added. So it went to 1.85. So that's around here. Very close to 2. Okay, maybe I should put it up maybe a little bit. Let me blow this up. There's more room to look at. Maybe right here. Okay. What do you think? I'm making these dots way too big. All right. So it's going up. Really not going up much. But hey, going up nonetheless. All right, let's do part D. Okay, let's do part D. We're gonna be very, very close to the equivalent point. I call it the be careful point. Okay, 12.4 milliliter. Oh, yes, right. If you remember titration, actually doing it, this is like 2 drops before it turns pink permanently. Okay, this is the point where I say, ooh, be careful, or else do it again. Wasn't that fun? All right, let's erase some of these things because these guys are gonna change. All right. Haha. Let's take a look at how this works here. Oh, let's go back to my lovely diagram. Okay, so I'm gonna add 4 of these now. 4 NaOH. That means I'm going to have Na and another OH. Okay. Oh, I make another water. So let's take a look at this beaker right here. How much H is left? Look at this lonely guy right here. And look, I'm the only one left. Everybody got married to an OH. Everybody found a partner except for me. I'm still the only one here. Looks like the acidity of this beaker is very, very low, which means pH is going to be higher. Now, how much higher? Let's not guess. Let's do the math. 0.0124 liters. So liters cancel. Okay. And that will give me 0.00248 mole. Okay, so that's how much HCl got reacted. And let's see how much is left. Oh, subtraction. That's an easy one to do. 0.00002 mole is left. Okay. Yeah. I hope so. All right. I'm not sure why I kept this number here. So let's figure out the new concentration. So look how low this number is. And that's not surprising because you only have one lonely proton here left. And concentration is 0.124 liters plus 0.025. And I need a calculator. This will be 0.00053. Okay. So as you can see, the concentration of HCl is getting smaller and smaller and smaller, which means when you plug these things into your negative log equation, you're going to get a number higher and higher and higher, and you will. My calculator says 3.28. Oh, finally, you're getting a little bit more of a significant jump. Okay, so as you can see, the amount of titrant added, okay, is not linear. Definitely not linear with the pH, because right now your pH is at 3.28. Okay, so at volume 12.5, so 12.5, so that's right here, you get a pH of around 3. Okay, 3.28, right? Okay, 3.28. 3.28, so right here. Okay. Let me make these dots smaller. This is I think that dot looks so big that it's going to confuse people when looking at it. Confuses me. All right. Are you guys okay so far? If not, you can always go back and rewind this if you're lost. That's the good part about this, I guess. Party. Okay. Party. I want to know, what is the pH when 12.5 milliliter of NaOH was added? Okay, now we're talking. Let's erase all of this, because all of this will make no sense. Okay, make no sense. Because right now, you are at equivalent point. Okay? Equivalent point. Looking at my drawing, right here, my beautiful drawing, this is going to be a 5. And this is going to be a 5. I'm going to add my final Na+. I'm going to add my final OH-, and even this guy got married. Take a look at my beaker. Okay, find H+. Bet you all my Pokemons that you won't be able to find any more H+, because there are none. This beaker right now no longer acidic. Okay, this is no longer acidic because there is no H plus concentration to negative log of. All right, now I have another video coming, okay, and that one's not so cool because they're gonna look at this. Sometimes this anion can generate OHs. Yeah, that's that crazy. Okay, some anion can say, "Hey, water, how are you doing?" So the Cl have the ability to say, "Hey, water, let's make OH." Okay, now the reason why that happened is because Cl is a conjugate base of an acid. If you know what I mean by that. I'm pretty sure you might not remember, but in my next lesson, okay, in part 2 actually of this lesson, I will actually show you exactly what I mean. Okay, but right now for strong acid and strong base, this is great because the amount of moles of NaOH and the amount of mole of HCl is now equal. So since there's no H's and no OH minus, these guys are neutral, these guys are neutral. What's the pH of neutral? That's right, lucky number 7. Okay, so at equivalent point, right here, at equivalent point, which is 12.5, your pH is going to be 7. Right there. Okay? So look like an exponential curve, huh? Looks like an exponential curve. Let's actually draw that in. No, let's draw it in later. Maybe not. All right, so let's go back. Okay? Let's go back and look at part F, the last part. Okay, I promise. No. Maybe we'll do 2 more parts. I'd like to illustrate a little bit more. All right, so let's erase this. We're not at equivalent point. Okay, so part F, what if 12.6 milliliter of NaOH added? Okay, so you look like you overshot, huh? You overshot by 2 drops. That's 1 milliliter. Not only are you going to be very angry, but in this case, I want to know what will the pH be, because right now it's no longer 7. It's going to be basic. It's going to be above 7. The question is how much above 7? How would this work? Now remember, last time we were looking at how much HCl was reacted, okay, with the amount of NaOH. Then we subtract by checking out how much HCl was left. Now we know that all the HCl was reacted. The only thing that's here is the amount of NaOH that is excess, isn't it? Let's go back to my lovely diagram. This is now 6, which means I decided to add Na plus and OH minus. Okay, it's getting a little crowded here. Can you see that there's no H plus? No, of course not. But do you see that there's an excess of OH minus? 1 OH minus in excess, which means this solution is basic. pH will be above 7. The question is how much? Okay, so what you want to calculate here is how much of this is excess right now. Okay, so let's do that very quickly. First, you want to find out how many mole of NaOH there is. So 0.2 moles per liter of NaOH. Okay, and looks like you have 0.0126 liter. Okay, and that will give you 0.00252 mole of NaOH. So that's the total mole of NaOH. Now, we know for a fact that these guys are 1-to-1, right? The amount of mole of HCl will be the amount of O of NaOH. That's a fact. So I'm going to do this calculation once, and I guess I'll never do it again. Okay, 0.0025 mole, okay, of HCl will react with the same amount of NaOH. Okay, thank goodness I picked HCl and NaOH, because if I pick something else, there's going to be just a little bit more work, just one calculation more worth of work. So that's the amount of NaOH that was reacted. Okay, now you want to know how much is excess, right? This is the amount that you put into your flask. This is the amount reacted already. So NaOH, in terms of excess, is 0.00252 mole minus 0.0025 mole. Okay, of course the answer is 0.00002 mole. By looking at the concentration, it's going to be 0.00002 mole. Divide that by the total volume, which is the original volume, 25 milliliters of HCl plus 12.6 liter of NaOH. That will give you 0.00053 molar. Okay, and to find pH, be careful here when you're finding pH, because you negative log this, you're gonna get POH. Right? Remember? Because this is the concentration of NaOH, not the concentration of HCl anymore. So pH is equal to 14 minus the negative log of this number. Okay? Don't make that mistake. And you'll get 10.72. Wow, what a big jump. 10.72 at 12.6. Okay, so if you're at 12.6, your thing is, what was it again? 10.72. So where am I put my dot? So 10.6. Sorry, 12.6, 10.72. So that's 10. That's right here. Okay, that's 10, yeah, right there, around there. Wow, looks like this thing is going vertically up, doesn't it? Look how slopey this is. This is crazy. All right, as I promised you, we'll just do one more, okay? We'll do one more. So let's erase this. Let's erase the amount of volume, because this will change. This thing inside the bracket is not going to change. This is going to change. This one. This one. This. Of course, this. That. And the pH. All right. Part G. Let's go big this time. Okay, let's pick a bigger number. Let's really overshoot this a lot. Let's say 20 milliliters of NaOH, because you just don't care. Okay, you're gonna release that, that nozzle and really make this very, very pink. And you'll notice that, whoa, the amount of mole you just added to this beaker is 0.04 mole of NaOH. So let's say you added, 8 of these things, and obviously now there's a whole bunch of OH minus in here. This is going to be quite basic if you ask me. All right, so you added 0.04 moles of NaOH. 0.0025 moles of NaOH of this will be reacted with the HCl. So what that means is that you will put 0.04 moles here, and you're going to find out how much excess you just put in. Okay, so let me say that again. This is how much you added in. Okay, this is how much that got reacted because of the amount of acid originally that was in there. Subtract the two number, you will find out exactly how much was left. And how much was left, 0.04 minus is going to be 0.0375 mole. Okay, so calculate the concentration. You will get 0.483. Okay, so again, as I said, this number is based on NaOH, so don't just negative log that. Make sure you might subtract that by 14 because you're looking at POH in this case. The pH will be 13.92. Okay, so at 20 milliliter, the pH is all the way going to be going up to 13.92. Hopefully 13.92, almost 14. My goodness. There you go. All right. Hey, let's call it it. Okay, and let's put this together. Okay, and no connected dots, okay? I'm not looking forward of producing a picture or anything. I want to know trends. You're not making no lines of best fit. You're looking at this and you're thinking, oh, what does it look like? Well, what it looks like is this, okay? It looks like you're moving very slowly in the beginning, very slowly, but somewhere down the line, this thing starts to jump. And it's going to go really, really high, okay? As you overshoot, you're going to go, you're going to go sharp. You're going to do this, okay? I know this is not beautiful. I'm sure you can draw something a lot nicer than what I have here. Okay, there you go. But this is a standard curve, or not standard curve. I shouldn't say standard curve because that's not how you use standard curve. But that's the titration curve for strong acid and strong base, based on, of course, that right here is your end point of pH of 7. Okay? So that's what happened when you titrate a strong acid and a strong base together. So if we were to do this in December, instead of looking at colors, we put a probe in there, a pH probe in there. And we have everything recorded onto that cell phone of yours. You'll notice that it will actually give you this curve. Okay, hey, maybe in September, ask Mr. Chung if you can do something like this, and he may let you use the new log thingy and do some titration and see if we're actually doing this right. Okay? All right. Anyway, I guess that's it for part 1. Okay, part 2 of this video, which is going to be on a separate file because I don't want you to download such big file at one time. You don't want to have a crash on you in the middle. At the same time, I think going through the whole thing would be quite overwhelming. So you're gonna have to download the part 2 of this, and part 2 of this is going to be based on strong base versus weak acid. Oh no. When that happens, are you going to get a curve that looks like this? I'm going to tell you right now, you are going to get a curve that looks like this, but however things is going to get shifted, I can tell you, it's going to look more like this. Okay, where the end point will definitely not be 7. Okay, the equivalent point will not be 7. It's going to be somewhere else, more basic, because you're titrating it with a strong bass. Okay. All right, look forward to that. Download that, watch it, and if you have any question, don't be afraid to ask me. All right, bye for now.